let's investigate the idea of factoring through the use of grouping. If we think back to our multiplication of two binomials, we can see that this x plus 2 must be multiplied by x squared and by 3. And that's what this step is showing us right now. And then that x squared needs to be distributed to the x and the 2, as does the 3. So in multiplying this out, we end up with 4 terms. However, if we want to rewrite this polynomial with 4 terms back into factored form, we can use something called factor by grouping. Factor by grouping you will use in many instances, but one recognizable instance is when you have 4 terms. So step 1 in factor by grouping is always look to see if you have a greatest common factor. And here, x cubed plus 2x squared plus 3x plus 6, there is no greatest common factor. Our next step is to group the first 2 terms and then the last 2 terms. So as you can see here, we have grouped those first 2 terms and those last 2 terms. Notice we have not changed the problem at all. We've put in parentheses, but if we took those parentheses out, this problem would still read the same. After grouping our terms, we move on to step 3, which is to factor out the greatest common factor from each binomial. So you can see that x squared is the greatest common factor of x cubed plus 2x squared. What is left is an x plus 2. And a 3 was the greatest common factor of 3x plus 6, leaving x plus 2. Notice then we have a common binomial of x plus 2. And that is what we're hoping for, because in step 4 it says that we're going to factor out that common binomial. So we've taken this x plus 2 and factored it out, and what is remaining then is x squared plus 3. And this was the original problem that we were multiplying. So factor by grouping is a way to move backwards from a 4-term polynomial into 2 binomials. In factor by grouping, we know our first step is to look for a greatest common factor. And in my first example, y cubed minus 2y squared minus 6y plus 12, there is no greatest common factor to take out. And in fact, example 2 and example 3 are the same terms written in different order, because we are going to be investigating the idea of if order matters in factor by grouping. Our first expression is written in descending order. Y cubed minus 2y squared minus 6y plus 12. And in grouping this then, after looking for our greatest common factor, we group our first 2 terms and our second 2 terms. Now we have to pay particular attention to how we group this. If I would group the negative outside, like I have just done in the example problem, I'm actually changing the problem, because in distributing it back in, I see I would have a negative 6y minus 12. This is different than our original. So what I'm going to do is I'm going to group that negative inside of the binomial. However, as this stands right now, it looks like multiplication of 2 binomials, which this problem is not. So last, I'm going to sneak in an addition sign. It's very important when having a third term as negative that you group it inside the binomial and include an addition sign in between, because adding a negative 6y is the same as subtracting 6y. Now, let's complete this factor by grouping. I am going to first take the greatest common factor out of my first binomial, which is y squared, leaving y minus 2. I'm then going to take out the greatest common factor of the second term, paying particular attention that I want the binomial left over to be y minus 2. So in this instance, with a negative 6y plus 12, I'm going to take out a negative 6. This is going to then leave me with y minus 2, which is what I want. I want that common binomial so that now I can factor out that binomial that's in common, y minus 2, and multiply it by y squared minus 6. You can see y squared minus 6, our second binomial right there. Okay, let's look at example 2 then to see if order matters. In example 2, I'd group my first two terms. I'd sneak an addition sign in there, knowing that my third term is negative. So looking to factor by grouping, I take out what is common in my first two terms, which is the greatest common factor is 1. Now don't discard that something with the greatest common factor of 1 cannot actually be the factor. Let's continue this. Then, looking at my greatest common factor of negative 2y squared minus 6y, I could either take out a 2y or a negative 2y. I'm going to take out a negative 2y, because what is left then is a positive y plus 3. Notice I'm using the same four terms, but I, in this instance, did not arrive at an acceptable answer because y cubed plus 12 is completely different than y plus 3. So this will not continue into a further factored form. So let's look at example 3 then. Is this saying that, yes, order of terms absolutely matters in factor by grouping? Well, example 3 again has the similar terms of y cubed minus 6y minus 2y squared plus 12. I'm going to group my first two terms, sneak that addition sign in because I see that my third term is negative, and recognize that I have not changed this problem. Next, I'm going to take out my greatest common factors. At first, my greatest common factor is a y, leaving y squared minus 6. And I'm going to take out a negative 2, leaving y squared minus 6. Completing this, I have y minus 2 times y squared minus 6, arriving at a correct answer. So, order of terms, it matters in some instances, although in others you can get there. In general, the rule that I have found most helpful is to always write your polynomials in descending order. Writing it in descending order is the best way to ensure that if factored by grouping, if the polynomial can be factored by grouping, it will be done in descending order.